Number 9, a 12 by 12 inch piece of metal. It's always some sort of a cardboard, metal, whatever. So you draw it, and I didn't even read it. It says squares are cut out of 4 corners. And so every time you have one of these kinds of problems where you're constructing your own, like an open top box, you cut squares out of the corners, and then you fold up the corners. And you should know by now that the height of the box, three-dimensional box, would be x, because you cut the squares out of each corner and you fold them up. So you can see this x goes up, and that's where that comes from. That's where the x comes from. And then 12 is the length of each of the sides of this square piece of metal. And so therefore, since we took an x and an x away from one side, the rest of it is 12 minus 2x. And so the length of the base is 12 minus 2x, and then we fold up this one, and we also have a 12 minus 2x. And all we're supposed to do is express the volume of the box as a function of x. So we already labeled our box in terms of just x, and so we can easily know that we can easily just write it down, because we know that the volume of a three-dimensional prism is the area of the base times the height, or you can think of it as length times width times height, whatever. But I like to put the x first, and then we could write x times 12 minus 2x, and then write another times 12 minus 2x, or we can just write it as 12 minus 2x squared.